Hello SAT champs, welcome back to the channel where we crush challenging math problems one step at a time. Today, we are driving into the 3K geometry probability combo question that's sure to test your conceptual understanding if you are ready. Grab a pencil and let's decode this problem together. A square has a side length of 6 units. A circle is inscribed within the square. If a point is chosen randomly inside the square, what is the probability that the point also lies inside the circle? First, understand the problem. The square has a side length of 6 units, so its area of the square is equal side square is equal 6 square is equal 36 square units, 6 times units. The circle is inscribed within the square, so the diameter of the circle equal to the side length of the square. Thus, the radius of the circle is r is equal diameter over 2 is equal 6 over 2 is equal 3 units. The area of the circle is given by the formula. Area of the circle is equal p times r square is equal p times 3 square is equal 9p square units. Set up the probability formula. The probability of the point lying inside the circle is the ratio of the area of the circle to the area of the square. Probability is equal area of the circle over area of the square is equal 9p over 36. And there you have it, folks. A challenging SAT question, unrevealed step by step. Remember, these problems are all about strategy and breaking them down piece by piece. If you found this helpful, smash the like button, subscribe for more SAT prep content, and share this video if you're satisfied. Got a question you are stuck on? Drop it in the comments or in the email, and we have tackled it together. Until next time, stay sharp and keep practicing.